example from scratch. So this week's assignment is playing around with 3D animation. You are ready to take on that third dimension, but there's lots of things you should know about how it works on like your 2D flat screen. First thing, as with starting any new kind of pen, remember to add your library p5.js, otherwise your code won't run. And it's always a good habit when you're starting a new pen, we should see that everything works. So there's your function setup. Let's make ourselves a nice canvas, create canvas. Let's make it 400 by 400 to start. And then I'm going to have my function draw. And let's see if we can get an ellipse to display at coordinates 100, 100 of size 50, 50. So I click run, I should see a circle. Yes, very good. Maybe then I'll include a background. That's a mild gray color. Run, and nice. So that's my canvas, 400 by 400 square. There's my code. I have my basic program running. Everything works. I added my library. That's always a good place to start. As I learn more and more languages, they kind of get jumbled up, and there's always like that hello world program or that first program you make just to get back into the sense of the feel of the language. Always a good place to start. Get a circle to display on the screen. Once you do that, then we can start making it a bit more complicated. So when working with 3D shapes, you need to add that third dimension to your canvas. So that looks like in Create Canvas, you add in a third argument, WebGL. When you type that in, it tells the computer, okay, we're working in 3 dimensions now. And then you notice there's a shift in your screen. Notice the circle was, let me see if I can get it to display again. It was in the upper left-hand corner, but when you add in WebGL, things kind of changed. Okay, click here. Let me delete WebGL. Notice it was up here. Run. That was the 2D 100 by 100. Remember, y grows down positively. And then your axes kind of change for 3D coordinates. Save and run. Now it moves down here. So what's happening? So this is where it's kind of hard to represent in the screencast because it involves using your left hand. So let's see, like that. Z goes out of the page. Your index finger should point towards the X direction. Your middle finger points outwards. Is that Z? And then one of these is Y. So I have a slide that reminds me of this. It's weird in computer programming because now you have negative coordinates. You also have that third axis to think about. So as a reminder, that's why I have this slide for this week. Yeah, so for like it's gonna confuse you even more if you're learning like 3D shapes in like math class because it's a different set of axes. So on 3D, here's the rule. The Z dimension is the axis that points away from the screen. And the helpful device to remember this is the left-hand rule, but everything else is right-handed. Dang, computer programming, why you gotta do left hand? So point your left index finger, that's the pointer finger, to the right, your middle finger downwards, and your thumb will automatically point towards you. So this is your left-hand rule. I kind of have this like X is your index, middle finger goes down, that's your Y, Z is your thumb. Notice this also points to how it grows. I believe when you point down like this, Y is positive going downward, just like it was before. But now you have this like near your face or far into the screen as your third dimension. So let's see if we can make sense of that when we translate it to a 3D axis with that circle. We should have gone positively 100 pixels in the X direction and then 100 pixels in the Y direction. When you added the 3D part to it, let me see if I can represent it. The origin, 0, 0, 0, is in the middle of your canvas. There's your positive X direction. That's your positive Y direction. Okay, that's the weird part that makes us use the left-hand rule. And then my pen right here, that's your Z direction. So do we see how the 100, 100 now makes sense? Question?
Does it give you is the Z infinite?
Kind of. Because you can have it very, very close to you, or even past your perspective, right? Like imagine a camera's like right here, right? You can have it be way out here. You won't see it. Just like how you move off the screen, you won't be able to see it, but you can make it so. Similarly, when going into the page, it does go like infinitely, but it's going to turn into a pixel by the time you get it that small. Right, so with what's currently displayed on the board, notice we moved right 100 pixels and down 100 pixels. Z hasn't changed, so it's still in this flat plane right here. That's why the circle is moved there. Good so far? It takes some getting used to. And now, notice, like, we're using a 2D, a flat shape in a 3D world. So that's kind of funny. Let's try to make the next thing, a box. So a box has 4 coordinates. An x-coordinate, a y-coordinate, a z-coordinate, and then the length, right? And all the lengths will be the same. Let's see if we can get a box to appear. Let's this time go negative 100, positive y, and nothing for the z, and let's have it be of size 10. We're going to save and run, and let's see what happens on our screen. Ooh. Okay. Let's see what happens when we draw it all in the middle. Perhaps that's a better place to start. 0, 0, 0, and then size 10. Save and run. 0, 0, 10. Is it there? Well, X, Y, Z. I think I spelled it right. Things are balanced. What happened to my cube? Run. Go. Yeah. So positive 100. How'd I break it? I didn't do anything that I think. X, Y, Z, 10. If you're done, you can bring it back to the next class. Huh. Yes? 10 should be the width. And so I had a box, but then the box disappeared. How did I break it? So I should be seeing a box displayed in the middle. I had it for a second, and then it stopped. So width in this case, save and run. Yeah, so let's consult the documentation. p5.js box. Box is your cube function. So here, so pretty much this code is your assignment. Notice to use your WebGL and there rotate. So box 50. Let's try that out. Draw a box with height, depth, x detail, y detail. With height, depth, box. Oh. Okay, so my mistake. So yeah, it's coming back to me now. It's been a while since I programmed in 3D. So when you're defining shapes in 3D, the coordinates are now separate from your shape. Notice here in the 2D dimension, you have x and y, correct? In 3D, you just define the width, the length, and the height. In order to move things around, you have to use translate. Because in 3D, everything is drawn in the origin. So there's a box. Notice it's always going to be drawn in the middle, unless I tell it to move somewhere else. Then,
Could you write the way on the board where the just the, like is it capital T or
that is something you can Google. I don't know off the top of my head. So notice here, right? You have a box, and then if you draw another box that's of size 100, it's going to cover the original one. And all that is drawn in the middle. Okay? Now, here's the new thing. Let's say you wanted to move it to the right. Translate. Now you have your x, y, and z. So we're going to move it right 100 pixels, none in the y, none in the x. My bigger box should be now shifted over. See that? It moved to the right. Now if I moved it from the left, notice the tiny box, that square in the middle, is like my origin. Now it's on the left. We'll move it back to where it should be, covering it up. Now let's go up, or really down the page. Right? It moved along the y-axis. We're going to have it jump up, because that's negative y. Now it's above. Oop. And then here's that new dimension. Into the page, out of the page. Positive z should come closer toward us. Right? It got bigger. We're going to send it back to the middle. It covers up our box, and then we go back into the page, and hopefully we'll see 2 cubes. Kinda. So the bigger cube is behind the smaller cube, so we see 2 squares. And now notice, if we draw a third box, let's have it move back to the right. Okay? Here's the weird thing. In 3D, let's say we wanted to create a tinier box of size 10. Click and run. It's drawn the same place as this big box is being drawn. And let's say you translated this one over, oops, you translated the second box over another negative 150 pixels. Save and run. But notice, right now my tiny box, I would have expected the tiny box to be like way over here. But instead, there was a net like negative 50 change in distance right this way. So translate, it's tricky because it all adds on each other. It's cumulative. Just like if you played around with rotations, they build on each other. So this one, because things are drawn at an origin, translate shifts your origin. The old origin was up here. The new origin after one translate would 100 pixels over to the right on the x-axis. But as you translate it 150 to the left, it's based on this coordinate, goes back over here. So from your original 0, 0 in the center of your screen, it's only left 50 pixels. That's going to really mess with you. So one way to address that, and this will be the last point I mentioned, is after you draw and after you translate, you should translate the origin back to the center so you know what the heck is happening. So after you draw your big box, notice now I'm going to undo that translation, put it back in the center. You moved right 100 pixels, now you're going to put it back in the left. And now with this change, you see that's 150 pixels to the left. X is changing. There's your original. There's 100. I translated it back. Now I go left 150 pixels. Okay, so that in a nutshell is how you start your assignment on getting 3D shapes to appear. Now I leave you to mess around with different kinds of 3D shapes. They have toruses, spheres, cones. You can mess around with color. You can mess around with rotation. There's also lighting and camera perspectives. So there's a lot of fun functions in there. And largely this assignment is exploratory, make some cool things. Maybe you want to create Mickey Mouse. One student did that last assignment. Or just make some like wacky shapes happen. So I'll post this right now so I don't forget. I think I forgot last week. And the time is yours to code away. There's roughly 23 minutes. You should at least have a